Hello, my favorite math guys. Today we're going to be starting some new material. We're moving into chapter 7 that focuses on rational algebraic functions. We're going to take this chapter and go backwards. We are going to begin by looking at how rational algebraic functions can be written as a ratio of two polynomials. This rule looks like this. F of x is equal to p of x all over q of x. And in this case, both of those stand for polynomials, and that is a ratio. Examples that you might have seen of these are as follows. You may see 3x minus 2 all over x squared minus 7x plus 11. And another example is x cubed minus 7. Remember, x cubed minus 7 can also be rewritten as x cubed minus 7 over 1 so that it is a ratio. In 7.7, we're going to be looking at the products and the quotients of rational expressions. One rule you need to remember, and yes, Will Ray, I'm going to say it, this is a review. This rule, in order to multiply fractions, x over a times y over b is equal to x times y all over a times b. A simple fraction that can be multiplied is as follows. 1/2 times 1/2 equals 1/4. However, moving into the new material, the multiplication of two rational expressions is accomplished in the same way. But instead of carrying out the multiplication, we're going to use factoring. That is why we spent the last day or so reviewing 7.3, which we spent a lot of time on in October. So if you need help with factoring, please ask me for extra help or go on to Khan Academy to do some extra factoring. But let's begin with a new topic. If you are asked to multiply a rational expression. Here is an example. If you are asked to multiply x squared plus 5x plus 6 all over x squared minus x minus 20 times x squared plus 3x minus 4 all over x squared plus x minus 2. To use that multiplication property mentioned above, you need to multiply the numerators and the denominators. I'm going to show you the next step that's in between. When you get really good at these, you do not need to use this next step, but it's helpful for those of you that might need to see how we move from step 1 to step 3. So here is the next step. We're going to combine our numerators. And in order to do that, in parentheses, I'm going to write x squared plus 5x plus 6 times x squared plus 3x minus 4 all over x squared minus x minus 20 times x squared plus x minus 2. Now, this step is not required, but it is showing you that same property you might remember from above. Now, the next step is to factor each of these polynomials. So, we're going to then factor x squared plus 5x plus 6. That factors into x plus 2 times x plus 3. We then are going to factor x squared plus 3x minus 4. That factors into x minus 1 times x plus 4. In the denominator, we then are going to factor x squared minus x minus 20. This factors into x plus 4 and x minus 5. We then are going to factor x squared plus x minus 2. And that factors into x minus 1 times x plus 2. So far, all we have done is combine our numerator and denominator and factor. Now, what you might notice is that we have several common factors in both the numerator and the denominator. What we can do now is remove those factors to simplify this. You will notice that there is an x plus 2 in both the numerator and the denominator. These cancel. You will also notice there is an x minus 1 in both the numerator and the denominator. These also cancel. The last factor that is common is x plus 4. Those also cancel. That leaves me with x plus 3 in the numerator and x minus 5 in the denominator. What you might remember is that we cannot have a 0 in a denominator of a fraction. If a denominator of a fraction is 0, the expression is not a legal fraction because its overall value is undefined. Therefore, it is not a legal fraction. So, for this, x cannot equal a positive 5. But we need to go back and look at the original problem because there are some other values x cannot equal. If we go back to our original problem, there are some other factors of x, once we factored, that also appear inside of the denominator. So, x cannot equal a positive 1 because of our x minus 1 in the denominator. X cannot equal a negative 2 because of our x plus 2 in the denominator. And x cannot equal a negative 4 because of our x plus 4. Because all of these values will give us a 0 in the denominator, this particular function, x cannot equal positive 5, positive 1, negative 2, or a negative 4. This has been an example of how to multiply and find the product of a rational expression. Your homework is to complete questions 1 through 4 on the attached worksheet to Moodle. Each of those problems are an example of how you can multiply different rational expressions. In order to do these successfully, you'll need to remember your factoring rules. If there is a GCF, remove it first. If you need any help, please reach out to me directly through email. And in addition, there will be videos posted on Khan Academy to help you.